Bueno, estamos de vuelta, son las 10:15 en Colombia. Y bueno, son las 10:15 en Colombia, estoy en el canal de español. No sé si Charlie tiene el canal en inglés. Sí, hola Charlie, ¿me escuchas con traducción en inglés?
Hola, thank you.
Can you hear English?
Yes. No, I only hear you.
Okay, so you have to press let me show you here. There's
The interpretation?
yeah,
the bottom?
exactly, and then
Okay.
put English there, and then you will hear, when I speak Spanish, you will hear English. Okay? Yep, that's it.
Yes, thank you. Perfect.
Ok, bueno, voy a seguir en español y espero que me estés escuchando ahora sí en inglés con la traducción simultánea que tenemos. Perfecto. Bueno, pues muchas gracias, Charlie, por estar el día de hoy aquí. Acabamos de tener otra empresa de Israel. Como estamos comentando, para nosotros Israel es un referente, obviamente, en estos temas de megatendencias automotrices, y es un país que le ha apostado y queremos claramente aprender de ustedes. Entonces, para nosotros es muy valioso también tener otra empresa de vehículos eléctricos o de soluciones eléctricas en el Autotech Week el día de hoy, el día de electrificación. Pues hoy tenemos a Charlie, es la CMO de ElectReon. Ella, antes de unirse a ElectReon, ocupó varios puestos claves en marketing y desarrollo de negocios en varias empresas emergentes israelíes, incluido Movit, que es una empresa también de soluciones de movilidad. Allí construyó y escaló equipos de crecimiento y fue responsable de múltiples y nuevos mercados y regiones para la compañía. Charlie tiene licenciatura magna cum laude en estudios de Oriente Medio por la Universidad College de London, UCL, perdón, y máster magna cum laude en estudios de sostenibilidad y medio ambiente por la Universidad de Tel Aviv, donde se especializó en modelos de negocio y financiación sostenible para proyectos de agua sin conexión a la red en el Global South. La empresa, bueno, ya como comenté, es una empresa israelí que está desarrollando una plataforma de energía compartida que proporciona carga inalámbrica para vehículos eléctricos en movimiento donde no es necesario parar a recargar. Hoy vamos a ver en la presentación de Charlie la carga inalámbrica y su papel en la descarbonización del sector de transporte mundial, al tiempo que se reducen los costos para los operadores de flotas. Bueno, entonces Charlie, voy a parar de presentar y ya puedes tú empezar tu presentación. Muchas gracias.
Okay. Just heading into the presentation now. Hopefully everyone can see this. So yes, thank you very much for the introduction. It's a pleasure to be here with you this morning. Just one small correction, I'm the CMO, the Chief Marketing Officer. I'm very privileged to work with a really strong team of engineers that came from Elbit Systems, another one of our big technology and engineering companies in Israel. So here today I'm going to talk to you about wireless charging and the role that we believe that it has to play in the future of electric vehicles and in decarbonizing the transport sector in general. So, apologies. So we can say today that more and more countries and regions have recognized and are committed to national deadlines to ban the sale of gas and diesel vehicles. And this is driving fleet operators and owners to develop electrification plans. And the world is now expected to move 1.4 billion vehicles to electric in the coming decades. Let's imagine that we need to replace half of these vehicles in the next decade. We must ask ourselves, do we have the global resources to support this shift? Can we do this in a sustainable way without exploiting our planet even more and without increasing carbon emissions when we need to manufacture the electric vehicles and predominantly the batteries, which are a big problem? Today, the common industry approach is to manufacture big and heavy batteries to cover range anxiety, something that we as private vehicle owners are scared of, but something that will impact massively fleet operators. They cannot operate if they don't know how long their vehicle will run for without being charged. Today, vehicles typically need to be replaced every 4 to 8 years. And we don't have sufficient, good enough recycling strategies in place for these batteries today. So some big challenges there. Fleet owners have more challenges in shifting to electric compared to private vehicle owners, actually. Existing plug-in charging stations, they limit their fleet operations and their business workflows. They require additional land allocation and building adaptations. They put huge pressures on our electric grids, and they cause fleet operators to charge mostly at nighttime, which is when the electricity is typically most expensive. They are not accessible for people with physical disabilities. The charging stations are not compatible with a future shift that we can expect in autonomous vehicles. And the physical charging stations are not suited to every location. There are many locations where land and space is very limited. Think about inside our major cities. Think about bus stations inside the city. Think about ports. Think about many locations like facilities where you have the loading docks, for example, for a commercial fleet, all really quite limited in terms of space. Another issue is around the charging downtime. It means that fleet owners need more vehicles in their electric fleet compared to their diesel or gas fleet, just to cover the downtime that some vehicles have. And so in short, when we summarize, large EV batteries and plug-in charging together result in high costs for fleet operators. And all of these issues are hindering fleet operators to actually transition to electric. It is easy for them to adopt 1 to 10 vehicles, but it's much harder for them to make the total shift to 100% electric. And so if I could summarize, the existing plug-in charging solutions that we have are just not enough. We need to be thinking about the next shifts in mobility, like I mentioned, autonomous vehicles, and we need to be thinking about how we can future-proof our charging strategies and thinking about how we can be more sustainable. So we believe that wireless charging is a big piece of the energy and transport puzzle that's missing today. We believe that it can accelerate EV adoption because it can be installed anywhere. It can be used at any time by anyone, and it makes charging completely accessible to everybody 24 hours a day. And ultimately, for the fleet owner and operator, it reduced total costs. And when we look at the bigger transport sector, it offers the maximum possible carbon emissions reductions for the entire global sector. So at ElectReon, we believe in transforming idle or dead time into charging time. So to enable this, we offer 3 modes of charging to suit any location. And the needs of many fleet operators can all be fit here. And we can transform waiting time or driving time into charging time. So if we see here our dynamic charging option, what we call a wireless electric road system, it charges vehicles in motion as they drive. Today, this is the perfect solution for fleets that drive on fixed routes like buses, BRT systems, and delivery fleets that run from point A to point B. And once it's installed in any road, it's already in place for additional EVs to use it in the future. So if we assume that fleets are going to make the fastest adoption of electric vehicles, if we deploy some of these roads in strategic locations, in 5 years and in 10 years, they're already in place for more public users, private vehicle owners to use the system. So it's a shared platform. Our semi-dynamic charging solution works well for vehicles that are moving slowly, like taxis, waiting to pick up passengers outside airports or train stations, or vehicles that are queuing to enter ports or logistics hubs. And our stationary charging solution, this third one here, is great for any location where vehicles park or wait for periods of time. We can deploy it directly under the loading docks for last mile and other logistics fleets. we can deploy it at bus terminals located inside the city or even at parking lots. And it's great because no space is taken up. Today, some commercial delivery and logistics fleets have a major issue of deploying charging stations, because once you deploy a charging station at the loading docks, you're stopping the vehicles from being able to maneuver in and out of the loading docks. So you're really impacting the ability of the fleet to move in and out and to do its job. Oh, sorry, jumped a few slides there. Okay, so let me talk to you about how the technology works. Sorry, my computer is going crazy. Here we are. Let me talk to you about how the technology works. So it's based on inductive energy transfer. It means that we transmit energy over the air from one coil to another. There are three main components in our system that you need to know about. Number one is the management unit. You can see that here and here. It's located at the side of the road or next to wherever the charging occurs. We call it the brain of the system. It enables power to be transferred first from the coil that's buried just under the road to the secondary coil, which is inside the receiver pad under the vehicle here. So you can see that in the photo, it's number 3 and number 4. So once they're directly above each other, energy is transferred. The management unit can be buried under the ground, like you can see here in number 2. And this is great for locations where real estate is very limited, any of the examples I've given so far. This is a real electric truck charging from our electric road system in Sweden. The vehicle is, the system is completely passive until the vehicle is directly above the charging pads that are underneath the road. And what makes our system quite unique is that it can charge up to 60 vehicles simultaneously. So one of these management units can power up to 60 individual vehicles simultaneously. And this is the same for the stationary charging. So whether we deploy it at any commercial facility or at a depot or a garage or a parking lot, it's the same. I want to share some more benefits with you here. So the system, as I've mentioned, is a shared platform for all types of electric vehicles. Once it's deployed, it can charge electric trucks, electric buses, vans, and private vehicles all simultaneously. All of the components can be deployed under the ground. So there's no visual impacts, there's no additional real estate use. It's, you know, what we're working on, and there are no physical hazards like there are with charging stations today, where it can be a barrier or a block, or the wires or the cables can be problematic. People can trip over them. None of that can happen with wireless because it can all be under the ground. Today we can deploy up to 1 mile of our electric road system in one night. So we're limiting the impact to road users. And of course, we can do that with planned engineering or construction work on any public road. And today we're working on an automation process for this deployment. So in the future, we will be able to deploy 30 or 40 miles in one night, or maybe even more. We're imagining a system that looks like this. So these are the coils that are laid underneath the road surface. We have receivers, as I've mentioned, that are installed directly under the vehicle. And we can complete the integration with any new vehicle in just 2 hours. It requires no change to the vehicle at all, so it can be done completely aftermarket. So far, we've integrated with multiple vehicles. Just to name a few, we've done integration with a Volkswagen van, a Renault private car, an Iveco bus, and several Stellantis vehicles, to name some of the big brands that we're working with. And the receivers are modular. This means that we can increase the number of receivers to meet the higher energy demands of larger vehicles. So for example, for a van, we would have 2 receivers. For a standard city bus, we would have 3. And then for a truck, depending on its size and energy requirements, we may have between 5 and 7 receivers. So I'd like to talk to you a little bit more now about how wireless charging can play a role in decarbonizing the transport sector. So while other companies are focused on optimizing batteries, we're focused on minimizing them. In 2 of our public projects, one in Germany and one in Israel, we've installed stationary wireless charging at the bus terminal or bus station, which is the first stop of a particular bus route. In addition to this, we've installed a short stretch of our wireless electric road system along the bus route. In total, in both of these projects, it's around 15% of the total length of the bus. And by doing this, we're able to charge the bus throughout its operational hours with regular top-up charging. And so you can see that here in this graph. Here is where it receives charge from the stationary charger at the bus station. And here is some charge it receives along the route. And this happens throughout the day continuously. So we maintain the state of charge of the vehicle battery continuously throughout the day, instead of what typically happens where a battery dies slowly throughout the day. So top-up charging like this is showing us that we're able to increase the operational hours of the vehicle with no change to the operations of the vehicle at all. And in Tel Aviv, we're demonstrating that the bus can run for 24/7 and without the need for an additional or larger battery capacity. In fact, we're able to reduce the battery capacity of these vehicles by up to 90%. For example, in Tel Aviv, our wireless electric bus runs on just a 42 kilowatt hour supercapacitor, instead of needing a 400 or 450 kilowatt hour battery just to complete a 12-hour shift. So on around 1/10 of the size of the battery for double the operational hours. And we do this, like I said, with no interruption to the fleet behavior. The charging occurs completely in the background. The driver touches a button and the charging begins. And it's very simple and effective. So now I want to show you one more example. So I wanted to give in Sweden with our truck that I showed you in a previous slide. It's equipped with just a 210 kilowatt hour capacity battery, and it still has extended range. And that's compared to typically needing 600 kilowatt battery just to drive around between cities or on highways. So we're showing here that by deploying strategic stretches of our wireless electric road, we're able to provide wireless charging to empower driving for longer. It's a great location, a great solution, sorry, for locations like transit corridors, so highways and toll roads. And once installed, it's a shared platform that multiple vehicles can use simultaneously. So now I want to talk to you a little bit more about how we believe wireless charging is the missing piece of the puzzle for some of our energy and transport challenges, which we believe come together and cannot necessarily be separated. So we've already deployed in several of our public projects some renewable energy generation on site. We might have some solar fences or solar power at the side of the road. And now what we're beginning to think as we build out our vision is deploying what we call solar fences with our electric roads. So having these fences along the road with solar panels tilted on top that can be tilted to capture sunlight depending on the hour of the day. We also think we can deploy this with our stationary charging, like at depots and at different facilities, anywhere where it makes sense. So wireless charging reduces the pressure on our electric grids. As you can see here in this graph, what we're actually doing by having this top-up charging is we're flattening the peak energy demand that you would typically have at nighttime hours, and we're spreading the demand mostly over the day. And so it also means that the fleet operator can reduce their required grid upgrade or grid capacity for their one location, unlike overnight charging. So wireless charging, when you have most of the energy being consumed during the day, it's great, because if we include solar panels, we're generating the energy during the day and we're consuming most of it during the day. By doing this, we're minimizing the need for energy storage. So we can reduce electricity costs by up to 2/3, depending, of course, on the location. And because we're generating the energy at the side of the road and consuming the energy in the same location, we're also eliminating the need to transmit and distribute the energy. So we can reduce electricity costs again, probably by another 1/3, depending on the exact location. And because of all of this, combined with the fact, that we're able to reduce the battery capacity by up to 90%, electric road systems are actually able to offer the highest possible CO2 emission reductions of all known technologies. This has been verified by independent studies in 2020 and 2021. And if we compare it to fuel cell technology, for example, electric road systems can reduce emissions by more than 67%. So a little bit more about our projects and about us. So we're operating today the world's longest wireless electric road. It's just over 1 mile and it's in Sweden. And we're the first company to show that an electric truck can be charged from a wireless electric road. In total, we have 5 public projects that are at various different stages today. We have strong global partners that enable us to do what we're doing. We're a technology first company. And so we need an ecosystem of energy and utility companies, of construction partners, of auto manufacturing partners, and many, many more to help us do what we're doing and to make an impact. And I mentioned earlier, we've integrated with multiple different vehicles from different OEMs, proving that the technology is vehicle and battery agnostic. And I think, when we put this all together and put it into perspective for fleet owners, we're showing throughout our public demonstrations that wireless is just more cost effective than plug-in charging options, because it reduces the grid connection required and energy cost, because it reduces fleet battery costs, and because at ElectReon, our system architecture is built to charge dozens of vehicles simultaneously. And these savings we're able to pass on to the end customers. In fact, when we think about our business model, we plan to finance most of the projects and to charge a small monthly service fee over the lifetime of the project to help accelerate electric vehicle adoption, which is our primary goal. And I'll just give you a brief overview to finish about our project. So we've been focused so far on Europe and the Middle East. We have this project in Gotland in Sweden that I mentioned. It's the longest electric road, wireless electric road in the world. It charges a bus and a truck. We have 2 projects in Germany. One has been deployed and one is currently planned for the beginning of next year. That's together with the German government and with Volkswagen. We have an interesting project with a toll road operator in Italy, which we will begin deploying later this month, actually. And there, what we're demonstrating is that if a consumer of a road is already paying for the service of the road, they will pay a slightly higher fee to receive charge from the road as they drive for that extra convenience. All of these pilots, all of these projects are just really the first step towards what we believe wireless charging can do for the transport sector. In Germany, in Sweden, in France, and in Italy, all of these governments have included thousands of kilometers of electric road systems in their national transport plan, and they plan to deploy those over the next decade and into the 2030s. And of course, we've been focused on Europe and the Middle East so far, but we're expanding now into the Americas. That's both North America, Central and South. And so this is pretty much where I finish. Thank you very much for listening today. If you'd like to get in contact with me, my email is charlie@electreon.com. Or if you just want to stay up to date with what's going on at the company and our new projects, you're very welcome to follow us on LinkedIn. And of course, we're looking for public projects that we can take on. So if anybody has any ideas or is thinking about partnerships, we'd be very interested in hearing. Thank you very much.
Well, Charlie, thank you so much for your presentation today. It is clear the benefits of what you're offering in ElectReon for, of course, buses and mostly public transit and also cargo. Well, we have now a session of Q&A. So we have one question here. Actually, it's one of the biggest bus producers here in Colombia for bus rapid transit. They are asking, I would like to know how much cost the cost per kilometer on the route, on the way.
Yes, absolutely. So we're targeting the price of $650,000 per kilometer today. And that's at scale. So, you know, today it costs a little bit more because we're only doing 1 to 5 kilometers, but at scale, we believe that these are the cost reductions that we can achieve. And I mentioned it briefly in the presentation, but we understand that public funding can be a barrier to getting public projects like this going. So we're very interested in financing the projects ourselves and then offering the service, the charging as a service to the end customers.
Okay, nice. Thank you.
You're welcome.
Also, we have another question here. It says, what is the impact of the streets and the, how to say it in English, the state of the streets?
Yes.
Traductor, ¿cómo se dice? El estado de las vías, ¿cómo se diría en mejor manera?
Okay. Yes, I understand. I think I understand
the
the
condition
question.
of the roads. Yeah, exactly. Because in Latin America, we have like not like roads like Germany or US. Sometimes we have some problems with the roads, some holes, you know. So
So I completely understand where the question is coming from. We get this one a lot. Yes, it's a popular question. So on average, and of course, it differs from country to country, and I can't speak on behalf of what goes on in Colombia, but typically we find that roads, the top layer of the road is scraped back and relaid every 10 to 12 years on average. So we've designed our system that goes under the road, the copper coils part. We've designed it so that it has a lifetime of at least 12 years. Now, so that means that every time that the road would be replaced, we would probably replace the technology that's under the road. Back in 2014, we did our first experiments with putting some of our pads underneath a road in Tel Aviv. So they're still there. There's been no change to the road surface or no impacts to the road that we have seen, and we monitor them on a monthly basis.
Okay, thank you. We have more questions also. Okay, so in environmental terms, could you tell us or expand how is important the reduction of the battery uses, and is better to use solar cells or wireless charging?
So I think it depends on the specific application, right? We, of course, need to be working on improving and optimizing vehicle batteries. But we can assume that a lot of the optimization on vehicle batteries has already been done. And so in terms of energy efficiency and capacity of vehicle batteries, we're probably almost there. I think the way to think about it is that maybe they can improve 3-fold from now, but they won't improve 50-fold. Of course, I could be wrong, but this is my understanding of what's going on in the battery development sphere. So we need to think about what our total amount of global resources is. You know, we know the massive impact that mining for cobalt, for lithium ion, for all of the other individual minerals that are required for all of the batteries. We know the impact. We know what mining does. We know, I mean, you know, in Colombia, you know what it does to habitats. You know what it does to local populations. And so anything that we can do to minimize the impact, I think, is important. And what we're saying here with ElectReon is that, of course, we need improvements in vehicle battery capacity and improvements in the technology. But what we also need to be looking at is efficiency improvements. And so our contribution to that is around decreasing the required battery capacity size and increasing the investment on the infrastructure side, which is shared and which won't need to be replaced as frequently as vehicle batteries. And in terms of the fuel cells, I think this was the question, right, around the fuel cells.
Well, it was about using less batteries and more charging with solar energy and also with inalámbric charge. So
yeah, so I think then on that part, it's more about what you can do to help the electric grid. I don't know how much our audience is following what's been going on in China in the past few weeks, but they're having huge energy shortages, which are a massive combination of many problems. But one of their issues is that they've dramatically increased the number of electric vehicles they have in their national fleet. You know, they have millions of electric vehicles in a very short space of time. And so they haven't necessarily planned for providing additional energy to power these vehicles. And so that's, I think, where renewables can come in. You know, you can have them on site. It could be solar. It could be wind power. You can have them at the place of where the charging happens, and you can minimize impacts on the grid and help the countries reach their renewable energy targets simultaneously.
Okay, thank you. There's more questions. So the next one is, since the battery is always kept charged and not fully discharged, how this affect or influence the battery life? And it doesn't extend it, improve the, you know, what's the benefits or, you know, of doing that?
Yes, absolutely. So I'm glad that this question was asked. So part of our ongoing research that we're doing is onto the impacts of what it means to regularly top up charge rather than letting the discharge go from 100 down to 0 and then charging the battery up again to 100%. So we've probably all experienced this with our computer batteries and with our mobile phone batteries, but ultimately the battery degrades with time. And through our ongoing research and analysis of the public projects that we have, we're finding that maintaining the state of charge between, let's say, 30% and 80%, rather than letting it go from 0 to 100 and back again, is keeping the state of health of the battery for a longer period of time. So it's actually enabling us to keep the battery in operation for more years. Now, we need to do much more research on that and much more analysis and make sure we're doing it across, you know, thousands of vehicles to confirm that. This is the general industry analysis. It depends, of course, who you ask and what their agenda is, but it's pretty much in line with what we're finding in other reports and other analyses.
Interesting, great. So we have a last question here. Let me check. Well, yeah. Is there any danger for people who is riding the bus, for example, someone that has pacemakers, or there's any study about the exposure to magnetic fields, or, you know, the charging itself? There's any problem? Have you, how that works? You know, there's any problem? Have you find any problem with that?
Yes, great question. Another popular one. And just last week, actually, we received our ECE R10 certification. There are many components and many, you know, safety analysis, but of course that includes EMC and EMF. And so our system is completely compliant with those standards. In fact, we're under them by, I think, a factor of 60. We've been doing some really interesting ongoing tests and analysis in the lab too. And I brought in my hairdryer, and we tested it, and it turns out that my hairdryer is emitting to me and to my head more EMC than the technology itself. You also need to remember that the technology is buried just below the road, right? So you have the road, then you have the air, the gap between the road and the vehicle, and then it's only at your feet. So it's actually much better to have it under the ground and away from the human body or the natural environment. So in short, we've received all of the certification, and there are no concerns or hazards whatsoever from EMC and EMF.
Okay, great, thank you. We have another question. I think the answer is yes, but can you charge the vehicles with people inside?
Yes, absolutely.
I mean, it's meant to be on the road,
yes.
with people inside driving. So yeah. So that's the idea. So I'm going to, well, not to Spanish. So there's any other question from the attendees? Please write the questions on the Q&A box or the chat box. We will read any of those. Okay, meanwhile, we have maybe another question or one last questions. And Charlie, we're really happy to have you here, to have you in the Autotech Week. All these technologies are really interesting for Colombia and for the people that are attending here. We have many people from government, from city councils, mobility secretaries of the cities, and also the Colombian automotive industry, motorcycle producers. So we are really looking what is happening outside. I mean, in terms of Autotech, in terms of the ACES trends, autonomous vehicles, connectivity, electrification, and smart mobility services. So for us, it's a great pleasure to have you here. Of course, if you want to get connected with any local authority or any local, let's say, bus traffic transit manager, or we can make the bridge. Of course, we would love to have you guys maybe doing some test of this technology in Colombia if it's possible in the near future. So yes, we will be happy to be a bridge for that. Okay.
Brilliant. Thank you very much, Alan. And I would just say that would be great. And one of the things that we find most interesting about Colombia is the fact that you guys are BRT pioneers. Yes. And it's a perfect mix. BRT technology and systems with wireless charging. And so, yes, we will be in contact.
Great. So yeah, let's keep in contact and let's see what is possible to do. So we have another question here. Yes. We still have 8 minutes for your presentation, so I think we can have a couple of more questions. Sure. So how you charge the energy to the vehicles? How would you charge? How they can pay for the service, to charge when the car is charging during the ride on the road.
How they can pay to pay?
How you can build. Yeah.
Okay, so the payment, there's a charge point operator and there's a mobility provider. So in this instance, ElectReon plays the role of both. We have software embedded into the receiver unit of the vehicle that communicates in real time directly with our system, and then it bills. It doesn't, today we're working with 1 or 2 vehicles in pilot projects, but we're building out the software so that the billing happens, depending on the way in which the end user wants to work, but it happens on a monthly basis, or it happens, by calculating how far we know that the vehicle will travel in a month, and the amount of energy that we know we need to provide to the vehicle. So we have very flexible models depending on how specifically the operator or the customer wants to work, but that software is included in the full package.
Okay, great. Let me see. Okay, that one is already answered. Okay, so I think we don't have more questions. Anyhow, it has been really interesting, all the feedback and interaction we had with the public today with you. So Well, thank you so much, as I say. Let's keep in touch. We are really happy to have you here. And so now I'm going to talk about tomorrow session. Also, you're invited if you want to attend. Everything will be in English and Spanish, so you can be also during the tomorrow session. So tomorrow's session will be the intelligent mobility services. We are going to have Mindtronic is a Taiwanese company that they are presenting their solution that is based on artificial intelligence. Then we are going to have Seat Code is the sub-brand of Seat, the OEM manufacturer, that is trying to change the Seat focus from only car manufacturer to a service provider. So that's really interesting to hear, because there's many Colombian companies also that once traditional companies from the automotive industry that would like to change or would like to jump from their traditional products to become a mobility service or to digitalize the company and offer different services just to keep up in these trends. Also, we have Trading Motion. That's a company that offers a really interesting solution for factories, automotive factories, of course, and Pop that is also offering community charging services or share charging services. So that's also a great opportunity to hear what they have to offer. They're from the US, from California. I'm going to switch to Spanish now, okay? Bueno, pues muchas gracias entonces a todos por participar y asistir hoy al Autotech Week. Cerramos ya la sesión de hoy, son ya casi las 11 de la mañana en Colombia. Y bueno, los esperamos mañana. El día de mañana, como les comenté, va a ser muy interesante y tenemos unos speakers que también nos van a contar temas muy interesantes y también nos van a dar una visión muy clara de qué han hecho ellos, por qué es importante estas tendencias y por qué la industria automotriz en Colombia debería pensar seriamente en apostarle a estas tecnologías. Y bueno, ese es el objetivo del evento de hoy y nuestro objetivo es de la Organización de las Naciones Unidas para el Desarrollo Industrial. Muchas gracias a todos los speakers, muchas gracias Charlie, muchas gracias a los traductores y a los asistentes claramente. Nos vemos mañana. Hasta luego.